Day 112 of doing a LeetCode problem every day until I get a job. All right, guys, we're back again. Another day, another LeetCode problem, but you guys already knew we would be here because we've been here for the past 111 days before this. So y'all know we staying disciplined and we're staying consistent, and we're not showing any signs of slowing down soon. But before we get started, don't forget, bring a mouse, bring a mouse right over here, y'all, and click that subscribe button for me. Then after you click that subscribe button for me, go ahead and smash that like button for me, guys. Then after you smash that like button, I'm calling all of my bankers. I repeat, all of my bankers to the comment section right now. I need y'all to drop 2 bank emojis in the comment section so we can run up this engagement and do our part in helping to build the Swift community by getting this content out to as many people as possible. And in order to do that, we got to boost the algorithm and do what we need to do. So go ahead and smash that like button and drop them comments, those bank emojis in the comment section so we can help build this Swift community together, y'all. Now, with all that being said, I know why y'all here. Y'all want to know what's up with this question. So today we have question number 2,974 minimum number game. The difficulty level is easy, so you already know we're going to keep the solution as simple and easy to understand as well, because we're all here to learn, and there's no point in writing code that nobody understands, because if you don't understand it, chances are you didn't learn anything, and we're all here to learn. So before we get into the code and we understand the code, first thing we need to do is understand the question. So let's see what the question says. It says you are given a 0-index integer array nums of even length, and there's also an empty array R. Alice and Bob decided to play a game where in every round, Alice and Bob will do one move. The rules of the game are as followed. Every round, first Alice will remove the minimum element from nums, and then Bob does the same. Now Bob will append a remove element in the array R, and then Alice does the same. The game continues until nums becomes empty. Return the resulting array R. So let's look at these examples so we can break it down and see what they meant. So first we have example 1. We have the input nums. It's an array of integers 5, 4, 2, and 3. Then we have the output is another array of integers 3, 2, 5, and 4. So let's look at the explanation so we can see what's going on here and how they got this output from that input. So it says in round 1, first Alice removes 2 and then Bob removes 3, right? So first it says every round, first Alice removes the minimum element from nums and then Bob does the same. So the first Alice removes the 2. And then after the 2 is removed, Bob's going to remove the 3 because 3 will be the next lowest element after the 2 is removed. So now that once Alice removes the 2, then Bob will remove the 3 because that's the next smallest element. When it's Bob's turn, that will be the smallest element. Now, first Bob will append a remove element in the array R, then Alice does. So Bob gets to append first. He removed second, but append first. So first Alice removed the 2, then Bob removed the 3. Now it's Bob's turn to append first. So Bob appends the 3, then Alice appends the 2. Then we start over. Then we continue. Then Alice going to remove the smallest, which will be 4. Then Bob will be left to remove the 5. Now it's Bob's turn to go first with the appending, and Bob appends a 5 first, then Alice removes a 4. Then Alice appends the 4. So it says, let's see what it says. It says, in round 1, first Alice removes 2, then Bob removes 3. Then in R, firstly, Bob appends 3, then Alice appends 2. So the R array would be 3, 2. So that's when Alice moved this, and then Bob removed this. Then Bob appended, Alice appended. Now we're working with this. Then it says at the beginning of round 2, we're left with nums 5 and 4. That's because Bob and Alice already removed the 2 and 3, so we're left with the 5 and 4. Now first Alice removes the 4, then Bob removes the 5, then which both append in the R and becomes 3, 2, 5, 4. So after Alice removes the 4 and Bob removes the 5. Bob goes first this time and Bob appends the 5, then Alice appends the 4. And that's how we get the output 3, 2, 5, and 4. Now let's look at example 2. It's a little less numbers, so it'll be easy, but hopefully it'll make it make sense even more, right? So we have the input nums. It's an array of integers 2, 5. This time the output is 5, 2. It says, the explanation says, in round 1, first Alice removes 2, then Bob removes 5. Then in firstly, Bob appends, then Alice appends, so it'll be 5, 2. So what happened is first Alice removed the 2, then Bob removed the 5. Because when we're removing, Alice goes first. So Alice removed the 2, then Bob removed the 5. But when we're appending, Bob goes first. So Bob has the 5, so Bob appends the 5 first. Alice has the 2, Alice appends the 2 second. And that leaves us with the 5, 2 output. So now that we understand how we got this output and what the question is asking, let's get into the fun part, the part we've all been waiting for, that good old Swift code, y'all. So now that we understand the question, the first thing we're going to want to do is we are going to want to declare a variable, and we're going to call that sorted. We're going to set that equal to nums.sorted. And what that is going to do is it's going to take the array of numbers and nums, and it's going to sort them in order for us. So it's going to sort them from smallest to, from smallest to greatest, so that we can work with the numbers and we can know which one is the smallest and which one is the greatest. Then after we do that, we're going to declare another variable called result, and we are going to pass result as an integer. Then we're just going to initialize it with a blank array. Or we're going to cast it as an array of integers, and we're going to initialize it with a blank array. Then we're going to come down here and we are going to say while exclamation point sorted is empty. So what this is really saying, with this exclamation point, is really saying while sorted is not empty, because that's what that exclamation point represents. It means while sorted is not empty. Then we're going to say let Alice equal sorted dot remove first. So Alice is going to remove, Alice is going to equal to the sorted array, the first element in the sorted array. So Alice is going to remove the first element in the sorted. And remember, it's sorted, so the first element is going to be the smallest element because we sorted it from smallest to greatest, right? Then we're going to do the same thing for Bob. We're going to say let Bob equal sorted dot remove first. So after Alice removes the first, then the smallest is already removed, and that's going to allow Bob to come in after Alice, and he's going to remove the new first. But we're going to the code is going to just look like this. Then we're going to say after Alice has removed her first out of the sorted list and Bob has removed his first out of the sorted list, then we're going to say result dot append dot append Bob, because Bob is going to be equal to the second smallest number because he removed the first after Alice already removed the first. Then we're going to come down here. So this is going to append the whatever integer Bob removed, right? Or Bob equals, which in this case would be the first of the sorted array. And then we're going to do the same thing. We're going to say result dot append Alice. So that means now we're going to append Bob, or first we're going to remove the first from the sorted with Alice, then we're going to remove the first from the new sorted with Bob, then we're going to append the element that Bob removed, and then after we append that, then we're going to append the element that Alice removed. Then we're going to continue doing that while sorted is not empty. Then we're going to come down here and we are going to say return result, y'all. And that should be all she wrote. Let's run it. Make sure it runs well, like it's supposed to. Let's see. And it's accepted, y'all. So let's submit it. Make sure it still submits. You know how these things go. You never know, but it should work. And there it is, y'all. 17 milliseconds beats 32.54% of users with Swift, y'all. That's what I like to see. Not too bad, not too bad at all. So get one more look at the code, y'all. One more look at the code. Hope y'all learned something today, and I will see y'all tomorrow for another day, another LeetCode problem. Peace.